Alright guys, here is question 8. Let's have a look at 8.1. It is a calculus questions here. So 8.1.1, it says here, take the derivative of 3x minus 5x squared in terms of x. So what you can do here, you will just come here. Remember what we are using. We are using this one here as our principle of derivating these equations here. I am Gaston Mapala. Welcome to Math with Gaston. If you haven't subscribed, please subscribe. We solely focus on pure maths from grade 10 up until grade 12. If you're looking for examples, past papers, you will find them here on this channel. Please help us grow. Give this video a like so that YouTube can show it to most different people thereof. All right, so now let's come here and say the derivative of 3x. We are going to be left with 3, and then here we take down the 2 times 5 is going to give us 10, and then 2 minus 1 is going to be just x. And that's how you would deal with a question like this one. Okay, so now 8.1.2, 8.1.2. so now if you look at this question here, you can't derive this question. It's not you can't derivate it this way it is now. So what you need to do now, you need to simplify first, make everything to be on a line. X squared minus 3 square root of, in this case guys, you must also know exponent rules in order for you to be able to simplify this. So what we can do here, we can say 2 minus, remember when you take it from the bottom, is going to be minus 2 to the power of minus 2, minus here is going to be x to the power of 7. This one here, it's to multiply by 1 over 3. So therefore what you have here, you're going to have 2x to the power of 2 negative 2 minus x to the power of 7 over 3. So that now that it looks like this, now you can take the derivative. Now you can say g of x prime is going to be equal to, now you bring it down here, you're going to say this times that is going to be what, minus 4, and therefore x, this 2 minus 1 is going to be minus 3 there, negative, you bring down the exponent 7 over 3, and then you minus 1 here on top. If you minus 1 there on top, you're gonna be left with x to the power of 4 minus 4 over 3 rather. Okay, so now you can either leave it like this, or you can simplify further and write it like this here. You can bring down the exponent the way it was before. Sorry about that. You can bring down the exponent the way it was before. You can say minus 4, then it's going to be over x to the power of 3 here, and therefore this one here you can just leave as it is because you can't simplify any further. There you go. Right, and that's how you would deal with a question like this one thereof. Okay, so now let's have a look at 8.2. 8.2 says determine the equation of a tangent to this function at x is equal to 2. All right, so what are they saying? They are looking for a tangent. Tangent, you know, that is a straight line that cuts the curve only at one point. So now what you can do here, you can say, okay, now let's go and find out what is the y value when x is equals to 2. Okay, so because what we're looking for the straight line function, right? So now you're gonna come here and say, okay, now f of x when it's equals to 2, you substitute it there, is going to be 2 to the cube minus 4 2 squared plus 2, and therefore 2 here plus 3. This will ultimately give us, if I were to punch this into our calculator, it is giving me -1. So these are the 2 points. Is going to be x is equals to 2, and therefore f of x when it's equals to is going to be -1. Okay, so what can we do now? We're looking for the gradient. We already have the 2 points. We're looking for the gradient. We know that number, in this case you can't use this formula y2 minus y1 all over x2 minus x1. You can't use this formula this time around, guys, because now you don't have 2 points. You only have 1 point, which is what? 2 and -1. So what can you do? But you will remember that if you take the derivative gives you what? It gives you the gradient. Okay, so now if you have got this function like it is here, x squared plus 2x plus 3, if you take the derivative of that, so it will give you what? Is going to give you the gradient. So now let's go. So you're gonna drop the 3, then -1 there is going to be 2, then 2, drop the 2 times 4, you're dropping this exponent here, is going to be 8, then you -1 there is going to be x, then here it's 1, you drop 2 times 1, it's just going to be 2, then you drop the exponent there, 1 minus 1 0, and then anything to the power of 0 is 1, and then the derivative of an exponent is what? Is therefore the derivative of a constant, rather. Listen to me saying derivative of an exponent. The derivative of a constant is 0. So therefore now what is the gradient? The actual gradient. So this here gives you what? Gives you gradient at any point. But we don't want gradient at any point. We want gradient when x is equals to 2. So now you would come here and say, okay, when x is equals to 2, what is the gradient of this function? Okay, then you substitute it there, is going to give us a gradient of -2. Right, so now you have got a point, you have got also the gradient as well. So this one here gives us the gradient, which is equal to m for this function. So therefore you're gonna come here. I prefer using this one at any point in time when I'm looking for the equation of a straight line. I prefer using this. So we do have our point here, which is x is equals to 2 and then y is equals to -1. So it's going to be -1 x -1 there, which is y, and then our gradient we already know it's -2, close bracket, and therefore you're gonna come here and say, okay, what is our x? We know that our x is given as 2. All right, so y plus, now you're just simplifying here, remove the bracket here, binomial -2x, -2 times -2, +4, then you take 1 to that side, so it's going to be y, it's equals to -2x there, +4, -1, so y is equal to -2x plus 3. So our answer is -2x plus 3. Now that's the equation of a tangent touching at point x is equals to 2. If you have a question, please drop it on the comment section below and let me know what you think of this question. I think it's a really good question, instead of them asking us to derivate from the first principle. But I think that will be the next question. 8.3. 8.3, there you go. 8.3 says if you're given this function, determine the f of x prime from the first principles. Okay, so now they're saying if they given us that, we need to determine from the first principle, so which is 8.3. 8.3.1. Okay, so what is the equation? The equation of x prime is given by lim as h approaches 0, f of x plus h minus f of x all over h. Okay, there you go. So now we're gonna have to substitute everything here. Where there's a space of x, we put that. Okay, so lim, you keep writing it, guys, don't forget it. You keep writing it. If you don't write it, you're gonna lose a mark or half a mark, so you must keep writing lim until h approaches 0. So what do we have here? We've got -6. Where there's x, we put x plus h, so it's gonna be squared, minus here into brackets -6x squared. There's a reason I'm putting a bracket, because there's a negative here, guys, so please don't make a mistake. Okay, over h. So we're gonna expand that. So it's equals to lim as h approaches 0. So let's expand that now. X plus h into x plus h. Okay, negative is going to give us positive x squared. There you go. There we go. H. Okay, for now guys, it's just gonna be algebra. We're just simplifying. So after expanding, you're gonna multiply binomial first times last times first. So now, because you guys are in grade 12, I'm going to allow you to do that. So I'm just gonna have -6 here. I've already done it. It's going to be x squared plus that times that is going to be, how much is going to be 2xh, and then h times h is going to be h squared, close bracket, plus 6x squared all over h. So I'm gonna continue up here. Lim h approaching 0. Here we go. Therefore, try to make it easy. Now we're gonna multiply throughout by this -6. Multiply everything with a -6. -6x squared, then 6 times 2, -12x h, therefore -6h squared plus 6 squared all h. Now you can see, now we can simplify. We've got -6h squared plus 6h squared. This one would cancel out. Therefore, if you have a look, we've got h there, we've got h here, we've also got the h at the bottom. So now what you can do now is to take out a common factor of h. So now let's take out a common factor of h. So we must keep writing lim as h approaches 0. So we remove h here as a common factor. We're going to be left with -12x and therefore -6h. Close bracket all over h. H and h would cancel out as h approaches 0 there. Is going to be -12x when h approaches 0 here. So this will be 0. So the answer is going to be -12x. And this will be our answer. All right, please let me know what you guys think of this one. If you are a little bit confused, please let me know on the comment section below. All right, so 8.3.2, it says write down how you will constrain the domain of f such that f inverse, the inverse of x is a function. So they like asking this question a lot, guys, a lot. So they just want you to know, you just need to know in this case on which instant will this be a function. All right, so now as you can see there, this is a parabola. This is a parabola. So what you can do here, you can say that, okay, you can say that you just need to know, let's say this is a function. Okay, so in this case, this function, it's like that. So they just want you to know if you were to constrain this function, actually doesn't touch it touches somewhere here. Okay, it touches somewhere here. They just want you to know if you were to break this thing apart, how will you ensure that this thing remains as a function? So it's for the, if you were to cut it here halfway, which is what, which is x greater or equal to 0 going that side, and then which part, so it's only gonna take this part here and also that part there. So it's only going to be less than or equal to. So if you take these 2 points, therefore this will remain as a function when you do the inverse. When you sharp x and y, then you need to constrain it between those 2 points. It will still give us a function. Okay, so 8.3.3, then determine the equation of the inverse for which the inverse is less or equal to 0. So what do you have here? 8.3.3. So this is our function here, y is equals to -x squared. So I'm writing it in terms of y, so that when we find an inverse, guys, you know what to do. We swap x and y, then we solve for y again. So let's go ahead and do that. Swap x and y. Okay, so x will come here, therefore y will go where x was. There you go. And then we're gonna solve for y again. So divide by negative 6, negative 6 and 6 cancel out. It's going to be square root, it's going to be x all over negative that. Therefore you take the square root of everything there, square root there, y is going to be equal to square root of x negative 6. So now can you see that if x is not negative, you're gonna have a square root of a negative number. So what you can do in this case, you can say you are going to constrain it for x less or equal to 0. Therefore this will ensure that all the answers that you have there, they are therefore positive, and then you won't have a negative square root. So as it is here, this was question 8, guys. Let me see you on the next one, where we will be doing question 9.